Hello and welcome to Chapter 6. This chapter we are talking about non-experimental research. So last chapter, in Chapter 5, we talked about experimental research and we talked about experiments. And I was going to try to be a wise guy and say that this chapter is everything else because this is all the non-experimental stuff. But you're going to see that in an upcoming chapter we're going to talk about quasi-experimental research. So this is, I honestly think of this more as kind of like observational / correlational research. So we're going to be looking at what happens whenever you can't control or don't want to control some of your variables. So this chapter really emphasizes the importance of what we call ecological validity. We've kind of talked about this a little bit already this semester. I've sometimes referred to it as external validity. But basically what this is, what ecological validity is the ability for your findings in the lab to generalize to the real world. So think about some of the research articles that we have read this semester already. A lot of them are very contrived, right? A lot of them are kind of like, so the story spoilers article, for example. I saw a lot of people mention that it wasn't like real life because those people weren't choosing the stories they wanted to read. They were assigned stories, and that's not how we typically read stories for pleasure, right? Or that that they're reading, maybe that doesn't apply to TV and movies and sports games and stuff like that, in terms of being spoiled on information. That is a problem with ecological validity. In other words, the things that they measured in that paper may not really generalize all that well to the real world. Well, why is that? There's a really hard balancing act that researchers have to do where they have to kind of balance validity internal validity and external validity, or internal validity and ecological validity. Which is to say that if you have a really tightly controlled study, that's good. It increases your internal validity, but usually it brings down your external validity with the more controls that you have. So what happens if you want to make sure that your study has ecological validity? And that's what we're looking at in this chapter, is what happens whenever you want to make sure that your study has good ecological validity and you can generalize it to the real world. A lot of researchers are interested in looking at how behaviors occur naturally in the real world and not just as a survey on Plato or that's distributed online. So one of my favorite go-to examples of this kind of research is Jane Goodall, and you may have heard of Jane Goodall. She was not really a psychologist, she was an ecologist, but she was definitely interested in behavior, and essentially she spent her entire career / life, well, let's say she spent the better part of the first half of her career monitoring chimps in their natural habitat. So a lot of what we knew before her time was looking at chimps that were either in zoos or in laboratory settings, and she helped us realize that there's a lot of really important dynamics that we miss out whenever we're looking at just chimps in captivity, that they behave a little bit differently whenever they are out on their own in their own little tribes, like creating their own little society and culture and customs and things like that, and the way they interact with one another. So she is kind of the patron saint of observational studies. Now, her method, and if you haven't heard of Jane Goodall before, I understand, like, whenever I was coming up through school, she was all the rage. Like, all the teachers always talked about Jane Goodall because she was kind of, at the time, the kind of big, peak, prominent, scientist of the times. I don't even know who that would be these days, I don't know. For a while, it was Neil deGrasse Tyson, the astrophysicist, but I feel like he's not really, on top, like as big as he used to be. I don't know. I have to think about that. But so why was Jane Goodall so famous? Because she participated in what's called naturalistic observation, and it is just like it sounds. Essentially, she would go out and she would watch her subjects behave in the real world, naturalistically observationing them, or naturally observing them. So psychologists do this too. Psychologists can, enter into, let's see, I'm trying to think of an example that's not going to give away questions on the quiz. So let's say if you're interested in looking at bullying on the playground, it's really hard to kind of get that to capture that in a laboratory setting, right? Because children are going to behave differently when they're in a laboratory, presumably. So it might be best to watch kids while they have recess and they're on the playground and look for bullies that way. Because if they're on their natural habitat, the playground, then that's where the behavior that we are interested in is occurring. And so we, by controlling that environment, by making it into a laboratory, we may not be able to see any bullying because people are changing their behaviors to match that setting, which is why it can be so important to observe things in the real world. So let me give you a classic psychology example of this. This is a fun one. So in 2001, some Canadian researchers, I think it's Catherine Graham and Samantha Wells, they were interested in aggression, specifically in bar settings. So how young adults get aggressive in a bar setting. And so these researchers, they basically went to this Canadian tavern for 93 nights. It was one actually very close to the university, which is why they specify that it's young adults, because a lot of the people in the study were college-age students. And so over 93 nights, they observed 117 aggressive incidents. So while that was happening, the patrons were not exactly aware that those researchers were there taking notes. They just probably saw them and thought they were just two people hanging out in the back corner, just like writing things and talking about, work or something. But really what they were doing is they were sitting there, they were kind of monitoring the situation on those 93 nights, looking for potentially, aggressive people, and they found that not only did it happen, basically there was 93 nights, there was at least one a night. And some of you who work at bars or bartend probably know these stats very well. But they found that 75% of the fights involved only guys, and about a third of them happened right outside the bar's premises. So the majority of fights took place in the bar, but a substantial portion took place outside of the bar. And if we're looking at the people who were doing the aggressive acts, it seems like most of them were exclusively males. So the researchers were able to identify a lot of things that could, quote-unquote, trigger bar violence, things that might happen to cause bar violence, problems with the bar staff, being drunk and rowdy, like being a little bit wild, stepping on somebody, bumping into somebody, that's usually how it starts, or interpersonal relationship problems where you have people who already don't kind of like each other and then they see each other at the bar and then they start arguing. Now, here's the thing. Would they have been able to identify these potential triggers for violence if they were doing this in a laboratory setting? You can imagine that would be very, very difficult to do because they'd have to recreate a bar in the laboratory and then hopefully invite people to the bar and hope that they behave as if it is a bar. But because there's a good chance that they are, if they were recruited for, here's a psychology study about drinking and aggression, most people are going to be on their best behavior, right? They know they're being observed because they're going to think it's going to make them look bad if they are hostile. So that is a classic psychology example. The thing that the reason why this is naturalistic observation is because Graham and Wells were posted at this natural setting. They did not intervene. They didn't start the fights themselves. They just kind of hung back and just kind of observed from the outside. So that's naturalistic observation. The other form of observational study is called the participant observation. And the participant observation is whenever one or more of the researchers become involved in the study and really kind of jump right into it. So an example would be if you wanted to understand what is college life like, there's a lot of different ways you can answer that. One is you could do a naturalistic observation where you just hang out outside of the dining commons and you just watch people and see how they behave. And that's one way you could do it. Another way to figure that question out, what college life is like, is by becoming a student, by enrolling in a college class, taking those classes, showing up, going to extracurriculars, joining clubs, going to parties with folks and things like that, making friends. What you're doing then is you're not only just observing it, but you are participating in that kind of behavior. So it's kind of almost like an anthropological kind of approach where you kind of get into it. And so there's not a lot of controls here, which limits our ability to draw good, firm conclusions from participant observation. But you can see how something like this can give you really invaluable perspective on this. So one really quick kind of personal example for me is that I think I've probably mentioned this already, that not long ago at all, I finished my history degree at Westfield. I already had, my psychology degrees, but I was just interested in kind of getting a history degree for fun. And so I enrolled in some college classes here on campus, and I was taking those. And it really helped me kind of see the workload that students have, the way that exams can be really stressful, and things like that. And those are all kind of points of view that I could have probably asked students, like, what are some of the things that you think are stressful about college life? And I might have gotten some of those responses, but by directly participating in that myself, I was able to see firsthand and feel exactly what it's like. So now I can have a little bit of a better understanding, a little bit of a better perspective on what college students generally kind of go through day to day. So let me give you a classic psychology example of this. I don't know if you've heard this one before. It's one of my favorite psychology studies. This is from Rosenthal in the 70s, and it's called Being Sane in Insane Places. And the premise was really, really interesting. Basically what he did, and this is the 70s, so back in the 70s, there's a lot of countercultural stuff in the late 60s, early 70s, where people were really kind of pushing back on cultural norms and things like that. And psychiatry and psychology were one of those things that people were pushing back on. And this was the era of, we were just now leaving lobotomies behind, but this is around the time of, electroconvulsive therapy, shock therapy, for treatments and things like that, and these, these asylums that were really crude and poorly staffed and treated people barbarically. So Rosenthal, kind of, being a little bit of a wild card here, a little bit of a agent of chaos, he decided he was going to come up with a study where he and his friends were going to enroll themselves into psychiatric hospitals and behave normally, and then see how long it took for them to be released. His suspicion was that as soon as people got admitted into the psychiatric hospital, that they would be perceived differently, that they would be stigmatized, and that they would be kept there, even if they didn't have any mental health problems. So his question, or his research, was all about, I wonder how long it'll take for people to realize that I don't have schizophrenia, or I don't have an obsessive compulsive disorder, and that I'm, ready to leave, that I don't need to be here. So individuals, including Rosenthal, went to different psychiatric hospitals around the country, and they began complaining of fake things, like they said they heard the word thud, or hollow, or empty, kind of as if it were like an auditory hallucination. The thing is that those are not really the kinds of words that people generally hear whenever they have schizophrenia and they have these auditory hallucinations, so it's already kind of weird, the symptoms that they're giving here. They're not really realistic symptoms. But almost every single one of them, after talking with the intake counselor said, yep, this sounds like schizophrenia, we need to hospitalize you right now. And then, once they were in the hospital, those participants just essentially stopped reporting hearing voices. So they told their doctors, I no longer hear the voice, and so on and so forth. But, and you can probably guess where this is going, they weren't set free. They weren't let out of the psychiatric hospital. Why? Because the psychiatrists, whenever they heard, oh, they're now telling me that they aren't hearing voices, is probably because they're lying and they just want to get out of here. They're not actually cured or treated yet. So that was the whole point of Rosenthal's study. He knew that was going to happen, and he could prove it with this article. So this is participant observation, because essentially he went in, he took notes, he involved himself in this process, but he was disguised. So the other folks did not know that he was a psychologist himself or a researcher. He thought he was just a regular person, and so did the staff. I got a really good story about this. I'll tell you, I want to try to keep these videos shorter than I have been, because I keep promising that 1 hour mark. But the story, the follow-up to this is too good to be true. So after the study came out and they published it, a lot of the administrators for these psychiatric hospitals were very upset, and they said, listen here, Mr. Rosenthal, that was really unfair what you did, and it was very manipulative, but we got our eye out for you and your cronies. If you send another one of those fake participants over here complaining of fake schizophrenia, we're going to send them right back to you. And then after a couple of months, Rosenthal started getting letters where this one administrator was like, I just want to let you know, I've already found 5 of your of the people that you sent to try to infiltrate my hospital, when in fact Rosenhan did not send anybody. So those administrators were listening to these people that claimed to have these kind of auditory hallucinations and assumed that they were faking it. So again, in the 70s, people were very concerned about, the state of psychiatry and psychology, and it really did its job of kind of getting people to think critically about those things. All right, so that's enough of the story time there. So there are some problems with naturalistic observational methods, right? So imagine that bar study. Imagine the study where Jane Goodall is out in the wilderness. What are some of the problems with that? The biggest problem I've already kind of talked about is that researchers don't have a lot of control here. And so far this semester, I keep championing the idea of controls because they help us increase our eternal validity. In other words, they help us ensure that what we are measuring is what we in fact are measuring, and it's not just some confound variable or a third variable that's controlling both of these things, that it is a legit, honest, behavioral change that we have witnessed, not just something out of our control. So, controls are really good, but sometimes we have to kind of be a little bit more lax on those whenever we are trying to make sure that our studies have good ecological validity. So, naturalistic observations are good, but they don't give researchers much control, which brings us to this other kind of flavor called the laboratory observation. Laboratory observation is essentially trying to recreate a naturalistic setting and then observing what the participants do in that setting. So probably the most common version of this is used for social psychology studies or for developmental psychology studies. So for developmental psychology, one very kind of popular task is called the strange task, and or the strange situation task, sometimes people call it. The premise is a guardian and their child go into a room together that has toys and whatnot, and then the guardian leaves the room for some indefinite amount of time, and they watch to see what does the child do whenever the guardian leaves. Does the child freak out? Does the child get curious and explore the toys? Does the child lock up and not do anything? Those are really good questions. They would do that in the laboratory. So the laboratory room looked like some kind of bedroom because it had toys and stuff like that around, but it wasn't an actual naturalistic kind of thing. So why is that important? By doing that, they might be able to look at, they can control how many toys are on the floor. They can control, how familiar those kids are with that room, which is to say that they're not familiar with it. So a laboratory observation tries to bridge these gaps by having some control, but also a lot of good external or ecological validity in its results. Okay, so there is some problems with but beyond that, there are some other problems with observational methods. One of them is called expectancy, and expectancy has to do with you, the observer. The others that we're going to be talking about today happen to the participant, so just keep in mind that the observer, or the expectancy happens to the observer. That happens to you, to the researcher. So, let's say that Jane Goodall, for example, if she went out into the jungle and her idea was that chimps are really, really stupid, that they're really, really dumb, what kind of notes do you think that she would take if she went in with the assumption that chimps were dumb? She'd probably see the chimps, kind of like picking off the fleas and the mites and stuff like that from their fur, and Dr. Goodall would probably be like, oh, these chimps are, they think that this hair is a good place for foraging, that this hair is a source for food. How silly is that? So if she was biased, her notes would be slightly different. Now that's a very extreme, kind of example there. But she might, kind of consider these more complex behaviors as kind of simple ones. Let's say that, to go back to the college example, let's say that you want to do participant observation. And so you want to know what it's like, what college social lives are like. And let's say that you go in and you suspect that college students love to party and they love to drink all the time. what kinds of activities do you think that you're going to be trying to do whenever you're doing this research? You're probably going to be gravitating more towards the bar scene, going to pubs and stuff like that, hanging out, drinking, smoking weed or whatever. You wouldn't be thinking about, these other things because your mind is already kind of focused on one aspect of it, and you secretly, maybe not consciously, you want to prove that that is right? And doing that means that you're unbiased. So that's called expectancy. And expectancy is whenever the researcher's expectations are going to influence the results that we get from the observations. That's expectancy. That's one of three that we're going to be talking about here. All right, so expectancy can be bad, like in those, or it's always bad, but it can have negative effects on behavior in terms of, like what you're looking for. But there's also some really interesting findings that those of you that plan on going into the education system should probably know about, which is the Rosenthal Info. Rosenthal Info, these folks, they started out looking at rat research. They would eventually kind of go on and look at elementary schools. But what they did is, in this first study, they had their class was being made to train these rats to solve these mazes. So just like you see on TV where, psychologists are always running rats through mazes for some reason. So they told half the class, hey, these rats that we got you, they are very, very, very smart. They learn very quickly, so just keep that in mind, that if they perform better than you think, it's because these are really smart rats, okay? So they told half the class that. They told the other half that the rats were maze dull, which is to say that they told that half of the class, like, look, I'm sorry, these rats are not very smart. You're going to need to be patient with them. You may need to work a little bit extra with them because they're so slow and they take a long time to learn things. And what happened was actually really, really surprising, and it still surprises me, to really think about it. That what happens is that the half of the class that believed their rats were gifted or were talented or were smarter than average actually did the maze better than the rats that the class was told were not super bright. So why is that interesting? Because basically the rats were exactly the same. The rats were all the same. They were essentially clones of one another. They were almost identical. They weren't bright or dull. They were just regular rats. But having those students believe that rat was smart somehow changed that rat's behavior to solve the maze faster. How? Well, there's lots of ways that could probably happen. It could be maybe that they treated the rat a little bit more carefully. It could be that that they gave the rat a little bit more time to explore certain things, or more time in certain areas, or there could be any number of things, right? The ways that we subtly treat people and things differently based on our expectations of them. And the opposite happened for the students that were told about that their rats were not so bright. Now, the reason why that's important is because, again, those two rats were essentially identical, and the only reason why they changed their behavior, the only thing that was different, is the instructions that they were given, and that, the second rat was told was not super smart, and they actually finished slower. So, to bring this back to the education system, they would go on to do this in an elementary school setting, where they met with these teachers and said, hey, just letting you know, for the incoming students that you have, here are some students that on their last standardized test showed some really remarkable grades, and we suspect that they are eligible for the gifted program. Please do not tell them, do not tell their parents this, but we think that they are gifted. And so just keep an eye on that student, okay? And what they found is that whenever teachers were told that those students who were picked totally at random, so they were lying about the standardized test scores, that those students actually did much better than their peers at the end of the year. So just the teacher's expectation that those students were gifted changed the academic outcomes of those students. They actually performed better, even though they were getting all the same education that that their peers were. There was nothing different except for the expectations of that teacher. How cool is that, right? All right, so that's expectancy. The next piece here is called the Clever Hans effect. Now this is a fun one because it involves this horse. This horse, his name is Clever Hans, and the idea behind the Clever Hans is that sometimes as you, the observer, you might accidentally change the behavior based on your presence. So why is it called Clever Hans again? Because of this gigantic horse right here. This horse, he was called Clever Hans because they thought that Clever Hans could do basic mathematics. You can even see here that they had on the chalkboard 2/3 plus 3/4 equal what? So they thought that this horse could solve these math problems, because what they would do is they would say something like, all right, Hans, what is 2 plus 3? And then Hans would start stomping his foot. Boom, 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 boom. And then he'd stop. And then they would say, he just tapped his foot 5 times. That's amazing. All right, Hans, what is 2 times 2? And then he'd go boom, 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 and then stop. He got 4. How did he do that? The way that he actually did that wasn't because he was a smart horse that could understand English and mathematics and perform it in front of a crowd. It was actually because what Hans was paying attention to was actually his handlers. That he began to realize that whenever he was about to land on the right number, that these people would usually take a deep breath and hold it and look at him. And that's whenever he would stop stomping his foot. And afterwards, he would get rewarded for that because he got the right answer, right? So what he learned was essentially to just watch these people stomp his foot until they get all uptight and then stop stomping, and then he gets food. That's the Clever Hans effect. So the Clever Hans effect is essentially that as an observer, you might accidentally change behavior based on what you are doing, completely unbeknownst to you. All right, and then the final kind of problem that we have with observational methods is called reactivity, or sometimes called the Hawthorne effect. And this is that people behave differently when they know that they are being watched. And you know this very well, because I remember in elementary school and in middle school, even in high school, the class would be a little bit rowdy, and then the principal would just kind of stop by. Sometimes he would sit in, or sometimes she would just stand in the doorway and just kind of watch things, but sometimes they would sit down and kind of watch for a few minutes. But the moment the principal showed up in our doorway, everybody got quiet. Everybody was on their very best behavior. Why? Because we knew we were being watched, and we knew that we were being evaluated, and we did not want to disappoint. The same thing happens in psychological research. Why is it called the Hawthorne effect? Because of this factory you see right here. Basically, the Hawthorne factory is in a town called Hawthorne. They produced lighting equipment. Right? No, it wasn't lighting equipment. They just produced like mechanical equipment. And these researchers stopped by. And said, you know what? We want to test the effects of productivity in different levels of lighting. And so they went around, and for a couple of weeks, they'd walk around with their lab coats and their clipboards, and they would take notes at what these workers were doing. So imagine that you are this worker right here, and somebody with a lab coat comes, and they're watching you handle this machinery, and they're counting how productive you are. Does that change your behavior? It absolutely does, right? You're going to pretend to be on task, right? You're not going to zone out or whatever because you want to make a good impression. You don't want to look like you're not doing a good job. So the problem is that those researchers, because they were interested in the effects of lighting, they started turning off some of the lights. And what they found is that they could turn the lights, almost all of them, completely off, and these workers, their productivity would barely change at all. Why did that happen? Because all of those people were worried about their jobs. They didn't want to get fired, so they worked even harder whenever the lights weren't out because they knew they were being watched. So when you're doing psychological research, you have to be careful, because the presence of you can impact and influence that person's behavior just because they know they're being watched. All right, so we're going to transition a little bit. Now's a good time to pause the video and step away if you need a quick break. All right, let's talk about qualitative measures. So far this semester, we've really emphasized the importance of empiricism and quantification. Quantification that's that really fancy word that just means that we like to be able to count these behaviors so that way we can compare those behaviors across groups, across time points, across conditions, and so on. So we like quantification. But not all of us are interested in doing that to behavior. There are some behaviors that we are interested in that we might not so easily be able to boil down to a single number. So, for example, if you are interested in understanding what it's like to live with a disability, let's say that somebody is paraplegic, so they have no functional control over their legs. Maybe one of the best ways to understand what that person's life is like is to get to know them and to ask them questions and to interview them, right? If we do that, though, that's not really a quantification, because we're not really turning things into numbers. We're just recording what that person's experience is like and then reporting on that. So there are sometimes that there are behaviors that we are interested in that we can't really boil down into numbers. And we're going to see that when we start talking about case studies. This is if you know Dr. Nick Morrison in our psych department, one of his specialties is qualitative research, which is, basically one of his specialties is interviewing people and then kind of using that information from the interview to help understand what it's like to be that person and understand their values and their challenges and things like that. So if you're interested in case studies, you're probably interested in not having to boil your participants' behavior down into simple numbers. If you're interested in having flexibility as a researcher, or if you're just not really all that interested in hard data, you don't really care all that much about control, then maybe this is for you. So here is an example. I'm not going to pull up the trailer and try to show it to you over this video, but I hope that you check it out. I'm going to put it in the lecture slide notes right here, but this is from a documentary called Project NIM. I think it came out in, I'm going to guess 2010, maybe 2008, somewhere around there, maybe 2012 at the latest. But Project NIM is a documentary about one of the very first attempts to get a chimpanzee to use sign language. And so they got this chimp and they tried to raise him like a human child. So they tried to put him in clothes, give him breakfast, he stayed in a home, he slept in a bed and all this other stuff. And they tried to use sign language to train him how to speak. So that is an example of a case study. The experiment here isn't really about, they can't give him this chimp, they can't give him a self-report survey and he can't fill it out, he can't tell them things, but they can watch him and try to understand what he is thinking or what he's doing by observing him. And if you do decide to check out Project NIM, it can sometimes be hard to find. I feel like it's almost never streaming for free on a service. You almost always got to rent it on Amazon or whatever, which is a bummer. But it's a great documentary, especially for those of you that you're psych majors, or most of you are. If you're interested in non-human research or the connections between humans and non-humans, it's a fascinating documentary, but it is a little bit depressing. It's a lot depressing by the final half, but very, very interesting. All right, so how is this done? How is qualitative research done? Most of it is going to be done in the form of an interview. So the researcher comes in, or they have a group of participants come in or whatever, and then they just ask them questions. How are you doing today? What is something right now that is bothering you? What is something right now that you feel good about? Asking these types of questions to kind of see what's on their mind. So it may not always be hypothesis driven. A lot of the research we've talked about so far, it starts with okay, you have to have a theory and a hypothesis, and then you design a study to try to understand if that hypothesis was true. For qualitative research is not as straightforward as that. A lot of times, qualitative research is done to explore a subject area, to help us understand something that we just really don't understand very much at all right now. So for example, you're not going to get a lot of this stuff with psycholinguistics. So psycholinguistics, or the study of behavior and language, has been studied to death. It's been studied so much. There's not a ton of case studies that use that because we already know so much about it. But we don't know all that much about, let's say, dissociative identity disorder, right? Or what used to be known as multiple personality disorder. So those cases are very rare. Maybe it's helpful for us to identify somebody who has that condition or report to have that condition, and you interview them, you talk with them, and you get some ideas, and that can help you form a hypothesis and a theory, because that can be the first part of the scientific method, which is kind of observing the world around you and observing behavior around you. The last thing that I will say about that is that if you've ever heard of Piaget, the most I was gonna say the most important psychologist. He's not the most important psychologist, maybe, but he's definitely up there. I would say Piaget is probably in the top 5 most important psychologists. But if you took a developmental psychology class, especially child development, you absolutely heard of Piaget. But his methods, he would just basically observe children interacting with the world, and he'd take a lot of notes, and then he would make these hypotheses, and then other people would come and test those hypotheses. So using qualitative research can be exploratory in nature. So the advantages is that you can essentially kind of use the information that you see to develop hypotheses, then you can test those hypotheses. But it's also going to be used a lot by social psychologists, anthropologists, and sociologists. We're going to use that less with cognitive psychologists. We're going to use it even less with like applied behavior analysis. With some forensics, you're going to see it, but really not a ton in forensics. Yeah, so you see it from time to time. So interviews and focus groups are common ways that people do qualitative research. So interviews are exactly like it sounds, where you would sit down with a researcher face to face and they would ask you questions. The 2 different flavors of that are standardized interviews and unstandardized interviews. Standardized interviews are, you come in, the researcher has 20 questions they want to ask you. Sometimes they might have follow-ups, but everybody gets the same thing. The second type of interview is called an unstandardized interview. And for the unstandardized interview, basically the researcher goes in there and then just asks questions, but isn't going to let that stop them from asking another question if it serves as a good follow-up. Does that make sense? Basically, one is standardized, where they have all the same questions, and the other one is a little bit more free-rolling. Like that. Alright, so the one example of this is the CAPS, or the Clinical Administered PTSD Scale. The CAPS is kind of the gold standard for PTSD diagnoses, where essentially the way this works is that you sit down with a therapist or with a counselor, with a clinician, and they ask you some questions and you report and they make notes about your answers, and then using that feedback they can give you the most accurate diagnosis for trauma, for PTSD, for post-traumatic stress disorder. That's better than just getting a simple questionnaire, which is usually how a lot of these things go because they're easier to do. They cost less. They're less time consuming to just get like a 20 question, or a 10 question inventory, and you bubble in or you circle, your answers or whatever. It takes more time to kind of do the interview method, but it's more accurate. So that's one example of interviews that we would see in psychological research a lot. The other kind of flavor of this, we talked about interviews. The other is focus groups. You've probably heard of a focus group before. You may have seen it on TV, where a bunch of random people get asked to come into a room, and then they usually will watch a video or they'll listen to somebody speak, and then they have to answer some questions about how something makes them feel. So, for example, here is... should I give this as an example? Yeah, okay, I'll give this as an example. We are in the process of totally transforming our core curriculum at Westfield. So we're really trying to change everything from the ground up, what core curriculum is. And it's a very, very, very time-consuming process because there's a lot of hoops you got to go through. There's a lot of licensing things you got to go through at higher education. But one of the things that the group that's leading this on our campus, one of the things that they're doing is they're doing a lot of focus groups. They bring in professors from other departments to come in, and they ask, and other students from departments, they have them come in and they say, what do you think about the core? What do you think about electives? What kind of changes would you like to be seen? And they listen to all these random people and their feedback. So it's kind of interviewing people in a group, and that makes it a little bit more collaborative sometimes. And then, so this would be a focus group up here, and this would be an interview over here, but that was probably a little obvious. Finally, we can have archival data. Archival data, I feel like you get more of it in sociology. You get more of it in communications. You get more of it in... yeah, I'll say criminal justice. You get a lot of it in criminal justice too. So you may not come across it that much in psychology, but essentially archival data would be like if you're looking at the behavior of someone who's deceased or somebody who you do not have access to, but you do have access to their writings, or you have access to their state records, or their taxes, or their demographics, or whatever. That you have this information, and you can kind of like look at these documents to try to draw conclusions about that person's behavior. It's a cool way of doing research, but the issue is that it's maybe the least control of all of these methods. So you got to be really careful when you're drawing conclusions from archival data. The advantages is that there's usually not like a ton of, or I don't know how to say it. I don't want to make it sound bad. If you're doing archival data, there's usually not as urgent a time frame on it. If you're dealing with humans and you're dealing with participants, you got to be places at certain times, right? You have to meet with people, you have to have people come into the laboratory and stuff like that, or you have to go out into the world and be around other people. With archival data, you can be a little bit more self-paced. You can, because you have all those documents, right? So it makes things a little bit easier that way. All right, so let's change gears a little bit now to talk about correlational research. So we've already talked about correlations a little bit this semester, but I want to go through this because you're going to see a lot of correlational stuff in just both in articles that we have coming up down the road, but also as a psychologist, you're going to see a lot of correlations, and it's your job to basically tell people that they are bogus and full of crap, or that they should be a little cautious in their conclusions in the way that they make generalizations. So when you're using an experiment, usually we try to manipulate a variable, right? We try to form groups, we try to make conditions so that we can try to understand causal effects of behavior. We can't always do that, though. For example, let's say that we were interested in this question. We think, or we hypothesize, that people who are tall live longer than people who are not tall. How do we test that? Unfortunately, I can't assign people to a tall group. I can't randomly do that, right? So I can't just go into a group of 100 people and say, all right, 50 of you, I want you to be tall for the next year. The other 50 of you, I want you to be short for the next year. Or short until you die and tall until you die. So you can't do that as an experiment. You can't randomly assign those things. So for that reason, sometimes we have to rely on correlations. We have to rely on looking for potential relationships between two separate variables. This other example, we'll talk about some of these when we talk about quasi-experimental methods in a couple of chapters. Another reason why we might not do an experiment is because sometimes it's unethical to do that. So if you think that smoking can lead to cognitive deficits and harmed health, then you can't assign people to a smoking group if you think that it's going to hurt their health, right? That's unethical for you to do. So that's another one of the ways in which we might need a correlational design. So again, this is going to be a review for a lot of y'all, but here are different scatter plots. These are how correlations are generally plotted out. So on the y-axis, we got up here is greater values, down here is smaller values, and then on the x-axis we have the exact same thing. So we got plus over here and then minus over here. And if we wanted to, we could say, all right, for example, this axis, this is going to be sleep, and this one is going to be appetite. And so what we are finding here is that people who sleep more, right? So they are so the values that are up here are also the values that are over in this direction. So that means that as people sleep more, their appetite goes up as well. But I don't know, I came up with that off the top of my head. I think I might be wrong about that. So if I am wrong about that, then what we're seeing is actually this, where we have sleep over here and then appetite over here. And what happens is that the more someone sleeps, so the more this goes up over here, the higher these values are, the further to the 0 point they are on the x-axis. So as one of these variables increases, so as appetite increases, the amount of sleep decreases. That's one way to think about it. Or as sleep decreases, appetite increases, whichever way. But what we're looking at here is a positive correlation and a negative correlation. So when you took a math class, when you took algebra, you certainly learned about like slopes and for lines, and you learned about like a positive slope and a negative slope. It's the same thing for correlations. If you see these kinds of lines like this, if it's kind of angled up and to the right, then you know it's positive. If it's angled down and to the left, then you know it's negative. And you can leave it as simple as that. But what about if you get this? Where is the trend here? Where is the relationship here? There isn't really one. There isn't really a case where as one of these variables goes further on one side of the axis that it changes on the y-axis. It changes them going up or down. We don't see that. And so we would say that there's no correlation here. The final version is this curvilinear relationship. One of my favorite examples of this is looking at, we could say that this is performance in sports and stress level. And so, and this is, it's also, hold on, I'm going to put performance on an exam, because we could just say performance generally, human performance, but I want to make it a little more concrete. So performance and stress follows a curvilinear relationship. So here, down in the sim, we have less stress. Here we have more stress. What are we finding here? We don't find a positive slope because we have a lot going negative over here. So we can't really say it's positive or negative. Instead, we can say that it's curvilinear. In other words, it follows a parabola, it follows a curve. So how would we interpret this? Basically what we're saying here is that as someone becomes stressed out, actually, hold on, this is upside down, where we're going to say up here is worse performance and down here is better performance. What happens is that as stress increases, people get worse at their performance on an exam. Whenever people are really, really, really unstressed, they're really, really laid back, they also do worse because maybe they're not thinking, they're not checking their answers, they're not, thinking about things too critically, they're kind of skimming over things because they're not stressed out enough to take it seriously. Which means that people do their best whenever people are just the right amount of stress. They have a little bit of stress, but not an overwhelming amount. That's a curvilinear relationship. And if you're curious about what that function is called, about performance versus stress, it's called the Yerkes-Dodson curve, and you can find about it online. So correlations are expressed using this value. They're expressed using R, so an R with italics, and the R with italics is going to essentially let you know the strength and direction of your correlation. And they falls between -1 and +1. -1, as you might expect, means that it is a negative correlation. In other words, that it has a negative slope. And if it is -1, that's as far as it can go in that direction, so it's an extremely negative slope. Consistently negative slope. If it's +1, just the opposite. It's a positive slope, but it's a very, very, very strong positive slope. It can't get any higher than +1. If it's 0, that means you don't have a correlation, you don't have a pattern. So to go back to look at these, I would say, for example, that this figure right here comes pretty close to having a 1.0 correlation because it's such a great line. Over here, this would probably be something like 0.7, positive 0.7. Down over here, though, for strong negative correlation, this one, again, looks almost like a straight line. So we're going to say that's -1.0, and then this is probably going to be like -0.7 or something like that. This over here is probably going to be 0, or it might even be like 0.01 or something really, really small. The closer it gets to 0, the weaker that correlation is. Alright, so here's a couple more examples for you. So this is an example of well-being versus deep talk. Deep talk is referring to how deep someone gets in their conversation. So how much depth people talk about things, like, are they a deep person? You know what I mean by that. Are they philosophical? Do they think about things really thoroughly and with interesting insights? What they find here is that there is a correlation, it looks like, or it looks like it to me. You can see this line right here representing kind of the trend line. It is positive because it's going up and to the right, but it's not perfect, right? It's not like this, it's not like that. So it's not a perfect correlation, but we know it's positive. And we know it's positive from the general trend here, which just means that the more often someone speaks in deep terms like this, the more likely they are to show higher levels of well-being. Here is a nice little kind of quick hand for how to interpret an R value like that, what we call the Pearson's R. If you have 0.5 or higher, that's going to be considered a large effect size, or sorry, a large correlation. If it's negative 0.5 or below, so getting closer to -1, is going to be large. If you have 0.1 to 0, then that's a very, very small or very weak correlation. All right. And we already talked about this, about like kind of, trying to estimate what the Pearson's correlations are. We talked about this too, about curvilinear. So we can see, if we look at this, it looks kind of like, oh, there might be a trend here and there might be a trend here. If you see that, it usually means that it's curvilinear. So it's not linear at all. It's more like this, right? So here what we see is age in years versus how much they've used the healthcare system. And we see that whenever people are close to 0 years old, they use the healthcare system a lot. Babies are needy. They have a lot of things that they have to get medicine for, or get surgeries for, and things like that. However, when we are old, we also have the same thing. We also have a higher likelihood of needing to use the healthcare system. In your 20s up to your 40s, that's whenever you're going to be using it at your minimum. And so we have this as a curvilinear relationship. It's not perfectly linear. It doesn't move in a straight line. Sometimes people will call this the U-shape or the horseshoe shape. And I already talked about the Yerkes-Dodson function, so I'm not going to go over that too. But that's what we talked about when we were talking about performance versus stress. So obviously you got to be careful about something, and what I want you to be careful about is that correlation is not the same thing as causation. And you know this because you've heard it in other classes before, you probably heard it on TV before, that correlation is not the same thing as causation. I think this is so important that I put it in huge big letters right here, that whenever you are reading an article and you find out there's a correlation, it doesn't mean that one of those variables is causing the other. We would need an experiment to help us understand that. So it doesn't help us understand causality. And I'm not going to beat this into the ground because we already talked about causality a lot last chapter. But in order for us to explain why behavior occurs, we need to know whether or not one variable causes the other, because that helps us explain why it happens. And you may remember that we had those three different kind of criteria for that. We needed covariance, we needed temporal precedence, so we needed to know we could manipulate that one variable came before the other one to see how that impacts the data. And we needed internal validity. We needed to know that there were no confounds or nuisance variables that were getting in the way. But what about this other thing, covariance? You may remember I mentioned something about correlations for that when we talked about it in chapter 2. So correlational research is good at getting covariance, is good at finding the mathematical relationship between those values, but it is very lousy at these other two things. So why is temporal precedence? So why is this thing right here about knowing which variable came first, why is that so hard to do with the correlational design? Here is an example. And this is one of my favorite examples of this, is stress versus sleep. They're negatively correlated. So if I'm trying to imagine what that looks like, it's going to look something like this, where I got sleep over here and I got stress over here. And if they're negatively correlated, that means it's going to look like this. So that as stress increases, sleep is at its worst, and whenever stress is at its worst, or at its least, sleep is at its best, is at its highest. The issue, though, so this is really helpful. It tells us that these two things are related. So it does get the covariance part of that equation correct. But the issue is that it doesn't tell us, is it the fact that we're losing sleep that is stressing us out? Or is it the fact that we're so stressed out that's causing us to lose sleep? That's a really important question, but not one that we can really answer using this particular setup, and we call that the directionality problem. The directionality problem is whenever we are unsure which of those variables comes first. In order to address that, we have to do an experiment. So that way, to use the same example, I could say, all right, I'm going to get half of you to sleep your regular hours, and this other half I want you to sleep just 2 hours for the day. We've already talked about examples a lot like this already, so you are probably already familiar with the directionality problem. The other issue is with internal validity, and internal validity is, remember, that's making sure that you're studying what you think that you're studying. In the context of correlational designs, having good internal validity essentially means that you you can't really have internal validity the same way you can with an experiment, but if you looked at a correlation and you believed that those two things were directly causal, then you'd be making a stance saying that you think that there's a lot of internal validity in that correlation. So here's an example of some problems with internal validity in a correlational example. There is, and this is true, there is a correlation between ice cream sales and polar bear attacks. It's a very strong positive correlation. So again, we can sketch this out. So I'm going to say that this is bear attack, and over here we have ice cream sales. And it's positive, so we know it looks like this. So what we're saying is that whenever there's a lot of ice cream sold, there's also a lot of bear attacks, which is very scary. Or we could say that whenever there's not a lot of ice cream sales, there's not a lot of bear attacks too. So if you think about this critically, what does that mean? Does it mean that if you sell a lot of ice cream that it's going to piss off all these bears and they're going to come running at you because you bought some ice cream? No, that would be ridiculous, right? That doesn't make any sense whatsoever. Could it also be that anytime somebody gets attacked by a bear, the town celebrates with free ice cream, so we have more people eating ice cream? No, it's not that either. So why is this a really strong correlation? The reason why is for this third variable. This third variable, which we are going, in this example, identify as the weather or the climate. So the third variable means that each of these variables are being controlled by an unseen, unmeasured other variable. So what do you think is the other variable that is impacting both ice cream and polar bear attacks? I'll give you a second to think about it. The answer is that temperature or the weather or climate, that those things are changing and affecting both of these things. As it gets more warm and more hot, ice cream sales are going to increase, and as it gets more warm, bears, specifically polar bears, are going to start migrating around looking for food sources that because they're running out of food in their natural habitats. So they're on the move, and they end up in these towns with terrified people, and it usually doesn't end well for anybody. So correlations can't really tell us if there is a third variable that is impacting this correlation. So another example of this would be how many automobiles you own versus your lifespan. And again, this is one of those things where it's a very positive, strong correlation that's been found many times. So why is it the case that the more cars you have, the longer you live? Give yourself a second. What variable could control both of those? What variable could impact how many cars you own and also impact your lifespan? There's a couple, right? You could think about it in terms of income, right? So if you have a lot of money, it means you're probably going to have more cars than somebody who doesn't have a lot of money. And it also means that you can usually afford better health care, you can afford better food, you can afford more safe vehicles and things like that. So your lifespan is going to increase as well. That being a third variable, net income is your third variable. Your third variable that is impacting both your automobile collection and your lifespan collection. Here is, I'll see if this works. this is kind of an old website, but if you Google spurious correlations or the third variable problem, you're going to get a lot of this stuff. I don't think it's working for me right now. Okay, here it goes. Here is an example of the number of people who drowned by falling into a pool is positively correlated with Nicolas Cage films. And so we can see over this time span, in red, we see how many people drowned in swimming pools, and in black, we see how many films Nicolas Cage is in, and it's a pretty close correlation, right? They seem to be very they're traveling together. Now, are they related at all? No. Or, here's another one. Per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. Very, very strong correlation, even stronger than Nicolas Cage. This is a 94% correlation, which is remarkable. So sometimes just random variability allows things to be correlated, and we call that spurious correlations. All right, so does this mean that correlations are bad? I don't think, and sorry, if you're wondering why I rushed over this, it's just because we went over this exact same figure in Chapter 5. So why are correlations so bad? I actually don't think that they are not that bad. I think that correlations can be helpful. It's just that correlations can't really help us explain why behavior happens. Or if they do, we have to be very, very cautious and skeptical about our ability to make those assumptions. Here's the thing, though. I think that correlations are a little bit of an underdog. I think they get a bad reputation in psychology and other areas of science because correlations can help us predict stuff. That's really, really important. So if we're going back to, let's say this one, for example, or for a second, stress versus sleep. I don't know which is causing which, right? But I do know, based on this pattern, if somebody is not getting a lot of sleep, they are probably also very stressed. So I can make a prediction using correlations without having to be absolutely sure about the causality. So I don't need to know why something happens in order to make a prediction. And if this sounds strange, you do this all the time because you might look outside and think like, oh, it looks like it's going to rain. And if I said, well, why is it going to rain? And you said, because that cloud is really gray. Why is it really gray? Because it's really thick with condensation. But why is that cloud thick with condensation and not others? And then you're like, oh, I guess I don't know. You don't need to know. You don't need to know why that happens in order to make a prediction about what's going to happen. It can help. Absolutely it can help. It's really important. It would make our prediction a lot better, but we may not always have the means or the ability to do that, so we rely on correlations. And that is all that I wanted to talk about here. I got pretty close with an hour, right? So that was faster than last chapter. Alright, so I'm going to pause this video real quick, and I'm going to go bring a dog to show you because you hung in here with me. So let me go get a dog. Alright, this is recording. Okay, cool. So this is Hopper. I think you saw him on the first chapter. He does not like this for some reason. I'm sorry, Hopper. Can I just get you to look at the camera for just a second? No. How about now? How about that? Can you see his face now? Yeah, so he's a very good boy. He's not quite a year old yet, and he doesn't really like being on camera. I guess he's shy, which is really weird because he's such a ham in the neighborhood. He loves to introduce himself to people. So, if you, I don't know, if you have a dog, send me a picture of your dog. I'd love to just get an email of your dogs. You don't even have to put anything in the body of the email. I just want to see your pets. And if you want to tell me about them, that'll be cool too. But yeah, thank you for tuning. You don't have to do that, obviously. I just want to get to know you and your family. But thank you so much for tuning in, and I will see you on the discussion forums. See you later.